Welcome to True Projects. In this video, we are going to explain about a project titled Pearson Correlation Coefficient Based Performance Enhancement of Broad Learning System for Stock Price Prediction. So now coming to the introduction part, BCPLS offers a promising avenue for improving stock price prediction through the integration of the Pearson Correlation Coefficient with the Broad Learning System. This approach holds the potential to provide more reliable forecasts in the volatile and data-rich world of financial markets, ultimately empowering investors and financial professionals with better tools for decision-making. The introduction of BCPLS is a response to the need for more sophisticated and reliable prediction models. It leverages the Pearson Correlation Coefficient, a widely recognized statistical measure of the linear relationship between two variables, to enhance the performance of the Broad Learning System, that is PLS. Now coming to the objective part for this project is to harness the power of the Pearson Correlation Coefficient to enhance the performance of the Broad Learning System for stock price prediction. By doing so, it aims to provide accurate, robust and interpretable predictions that empower individuals and organizations to make informed financial decisions in the dynamic and competitive world of stock markets. Here we have improved predictive accuracy. One of the central goals of BCPLS is to significantly improve the accuracy of stock price predictions. Second one, here we have robust performance. It aims to create a robust and reliable prediction framework that can adapt to changing market conditions and handle noisy, high-dimensional financial data. So now coming to the requirements part, here we have two types of requirements, hardware requirements and the software requirements. And hardware requirements, operating system as Windows is required, processor i5 and above, minimum 8 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirements part, Anaconda 3 is required and Visual Studio Community version is required. So now coming to the flow of work, here first we have importing the packages. This step involves necessary importing the packages, Python packages for data analysis, machine learning and visualization. That are NumPy, Pandas, Matplotlib for visualization. Second one, here we have exploring the dataset using Finance and AAPL data. This step involves loading the data, understanding its features and structures, and identifying any missing or corrupted data. Third, here we have data processing. This step involves the cleaning the data, removing any outliers or missing values, that transforming the data into a format that can be used by the machine learning model. Here first we have Pandas data frame. It is a Python library for data analysis. It can be used to load, clean and manipulate data frames. Second, here we have Keras data frame. Keras is a Python library for deep learning. It can be used to load and pre-process data for deep learning models. Fourth, here we have visualization using Seaborn and Matplotlib. This step involves using visualization tools to explore the data and identify any patterns or trends. Seaborn is a Python library for statistical data visualization, and Matplotlib is a Python library for plotting graphs and charts. Fifth, here we have feature selection. This step involves selecting the features that are most relevant to the machine learning task. Next, we have data splitting into train and test. This step involves splitting the data into a train set and a testing set. The train set is used to train the machine learning model and the testing set is used to evaluate the model's performance. Next, here we have building the model. This step involves training a machine learning model on the training data. The model can be a linear regression over here, a support vector machine, a support vector regression model, or any other type of machine learning model. Next, we have AdaBoost. AdaBoost is a boosting ensemble model that works by training a sequence of weak learners and then combining them to form a strong learner. In this first, we have gradient boosting decision tree. Gradient boosting decision tree is a boosting ensemble model that works by sequentially adding decision trees to the model. Next, here we have random forest. Random forest is an ensemble model that consists of a collection of decision trees. Next model, here we have bagging, which is an ensemble model that consists of a collection of decision trees, and the model named as MLP here, which stands for multi-layer perceptron, is a neural network that consists of the multiple layers of neurons. Next, we have voting regression. Voting regression is an ensemble model that combines the predictions of multiple regression models. And the model, which is named as CNN, which stands for convolutional neural network, it is a type of neural network that is commonly used for image recognition tasks. Next model here we have LSTM, which stands for long short-term memory, is a type of recurrent neural network, that is RNN, that is commonly used for natural language processing tasks. And the model here we have, which is named as GRU, stands for gated recurrent unit, is a type of RNN that is similar to LSTM, that is long short-term memory. GRUs are able to learn long short-term memory dependencies in sequences by using gates to control the flow of information through the network. Seventh, here we have loading packages for PCC-BLS. PCC-BLS is a statistical package that is used for analyzing panel count data. Panel count data is a data where each observation represents a unit that is observed over multiple time periods. And then here in next we have data set review of data. The data set review of data is a process of inspecting the data to ensure that it is clean and ready to be analyzed. This involves checking for missing values, outliers, and inconsistencies in the data. Next we have converting the date. This step involves converting the date column in the dataset to a date time format. This is necessary for the some machine learning algorithms such as LSTM that can learn temporal relationships between the features. Next we have Pearson correlation coefficient. The Pearson correlation coefficient is a measure of the linear correlation between two variables. It is a value between -1 and 1, where 1 indicates a perfect positive correlation and -1 indicates a perfect negative correlation and 0 indicates no correlation. The Pearson correlation coefficient can be used to measure the correlation coefficient between the stock price and the PCC-BLS index. Next we have visualize correlation of PCC-BLS. This step involves using a visualization tool to visualize the correlation between the stock price and the PCC-BLS index. This can help to identify any patterns or trends in the correlation. Next we have predicting the stock graph. This step involves using a machine learning model to predict the future stock price. The model can be trained on the historical data and it can then be used to predict the stock price for the future dates. Here we have training the model. This step involves training a machine learning model on the historical data. The model can be trained using a variety of machine learning algorithms such as LSTM, random forest, and support vector machine. Next we have building the model with voting classifier, since it gives better score comparing to the other models. So here this step involves building a model that combines predictions of multiple machine learning models. The voting classifier is a type of ensemble model that can improve the accuracy of the prediction by combining the prediction of different models. Next we have Flask framework with SQLite for sign up and sign in. This step involves using the Flask framework to create a web application that allows users to sign up and sign in. The Flask framework is a Python framework that is commonly used for creating web applications. SQLite is a lightweight database that can be used to store the data for the web applications. Next we have importing the packages. It is similar to the earlier ones which I have explained. This step involves importing the necessary Python packages for the web application. The Python packages that need to be imported will depend on the features of the web applications which we are using in this project. Next here last we have user gives input as feature values and symbol of stock. This step involves the user providing the input values for the machine learning model. So now here we have the given input is pre-processed for prediction. This step involves pre-processing the input data to make it suitable for the machine learning model. This can involve removing outliers, transforming the data, and scaling the data. Next we have trained model is used for prediction. Trained model is used for prediction. It involves using the trained machine learning model to predict the stock price for the given input data. And the last one here we have final outcome is displayed through front end. This step involves displaying the prediction to the user through the front end web application. The prediction can be displayed in a graphical format such as a chart, or it can be displayed in a numerical value. So now coming to the execution part. To execute the project, first we need to open the code folder. So here you can see that we have a folder which is named as static. This folder consists of files related to CSS, JavaScript, and Bootstrap files. And the folder named as templates, this folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Next here we have app.py file, which likely contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing as a request, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Next here we have signup.cv file, which appears with the database file which is used to store the information over here. And the file dataset which is named as AAPL and the prices are the two .csv files which is datasets which is used in this project. So now just copy the path from here. Open the Anaconda prompt. Type the cd command followed by a space and paste the path over here, and now just hit the enter button. Now type python app.py and now just hit the enter button. After running the app.py file, the Flask framework will host the application link locally at the default address in port 5000 unless configured differently. Here you can see that the link has been posted over here. Just copy this link and paste it into any of the browsers. Here I am using Chrome. Just paste this link and now hit the enter button. So here you can see that this is our home page. By clicking on the sign up button here, you can simply do the registration over here. I have already done the registration by entering the username, first name, email, mobile and password. So I am clicking on sign in button. Now just enter the username and the password over here which you have created while doing the registration, and now click on login button. So here you can see that it is a stock price prediction. So just enter the open price, high price, low price and stock volume. So suppose that I am entering this price and the high price is 2. For the low price here I am entering 5, and for the stock volume here I am entering 2. And now just simply click on predict close price button. Here you can see that the closing price is predicted as -8. So depending on the values you have provided over there, it will predict the stock price prediction. So now click on the symbol base button. So here you can see that enter the stock name over here and submit. So suppose here I am entering BTC and most recent stock detection. By clicking on the submit button, here you can see about this. So here you can see the most recent stock date is this. For the open price, here you can see BTC open stock price of this, and the close price is showing over here. The latest close price in the dollar and the next day price prediction the $1.90. So now just click on the about button. Here you can see that there are many different graphs using many different algorithms, and based on the different algorithms, here we are getting the accuracy of different algorithms over here. And now just simply click on the sign out button. By clicking on the sign out button, you can simply log out with it. So now coming back to the conclusion part, BCPLS has made significant strides in advancing stock price prediction by harnessing the power of Pearson correlation coefficient and integrating it with a broad learning system. This research endeavor holds the potential to empower individuals and organizations with more accurate, robust, and interpretable predictions, ultimately assisting them in navigating the complexities of the financial markets and making informed decisions in an ever-evolving landscape. Through its integration of the Pearson correlation coefficient, BCPLS has achieved several notable outcomes. Voting regression, linear regression is built as extension for feature values, and linear regression is used for prediction since it gives better R2 score and MSE value comparing with other models. So here we have completed with our project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.